the graph of a function f is given. Use the graph to find the values, if any, at which f has a local maximum. What are these local maxima? The values, if any, and notice it says values, it's not saying coordinate points. So we're going to be looking at y values. If any, at which f has a local minimum. So the first part is a x value, the second part is a y value. And this is how I would approach this particular problem. Local max. And this kills two birds with one stone. Yeah, I probably wouldn't be able to hit one bird with two stones. So maximum means I'm looking for a hill, right? This is your max. What's my local max? It looks like it's y equal 1 at x equal what? 0. That answers both of those questions. X is where it occurs, and y is what it is. And then it says local minimum, and I notice he has two valleys. They both have a value of -1, so it's going to be -1 at x equal minus pi and x equal plus pi. Where does it occur? It occurs at plus and minus pi. What is it? -1. Now, absolute maximum and minimum, if it exists, is the largest or highest that a function gets. In other words, I could have a bunch of hills. The highest of the hills in my world is the absolute maximum. The lowest of the valleys in my world is the absolute minimum. So you can have many maximums, but there's going to be the biggest of the big. So you line up all the big and say, who's the biggest? That's the absolute. You line up all the smalls. Who's the smallest? That's the absolute. And by the way, absolute can occur in one of two places. It can occur at a hump or valley, or if I have a solid dot like I have here, this can occur at an end point. If it's an open dot, that's a different issue. It says, find the absolute maximum and the absolute minimum. Now we're looking for y values. They didn't say what the x value is. They say, what is the absolute max, absolute min? That's a y value. And if I look at it, here's the big. Is there anybody bigger? No. This endpoint is below this hump. So the absolute max is going to be, I'm going to go ahead and just put in y equal 4, because you've got an x equal 4 there too. Now I'm going to look at what are the low points here and here, because that's a solid dot. And you say I can include the endpoints. Who's the smallest? Between -2, y1, and y0. Who's the smallest? y0. Of all the possibles, who's the smallest? Y equals 0. Here's the big, yes.
Did you write absolute max and absolute min the same way you do local min and local max?
Yeah, except for the fact that absolute says you're going to look at all the locals and who is the biggest of all the locals, or who is the smallest of all the locals.
Right.
Yes?
When they ask for local, will they usually give just a or a domain? Or
Yes.
Okay.
Well, you could have many locals, however, even if over minus infinity, infinity, you say, well, if you had something that had a bunch of humps, you could have many locals. So, but you're normally looking for locals over a region. And you say local means the valley, or local means the state of Arizona. So you're usually, if you're looking for locals, you're looking over a region.
So local is always X value and...
No, local is everything. If I'm looking at max and min in general, it's always the Y value at some X value. Local means basically you're looking at a particular region. There can be many locals. I look through the valley. What do you have? You have Squaw Peak. Oh, I guess Paesta, I have problems with that. Paestawa Peak. You have South Mountain. You have Camelback Mountain. There are many peaks in the valley. Those are all local maximums. But of all of the peaks in the valley, who is the biggest peak of them all? That's the absolute maximum. So you can have a lot of locals, but there can only be one absolute. And they're all Y values. Okay, here's the fun part. But you already know what this is. You just don't think about it. That's like my calculuses. We're doing this now. Rates of change. So they know what it is. They just never attach proper words to it. It says, if A and B, A not equal to B, are in the domain of a function, y equals f of x, the average rate of change from A to B is defined by delta y over delta x, f of b minus f of a over b minus a. Who is this? Who is this? There you go. It's y2 minus y1 over x2 minus x1. This is the slope of the line. That's all it is. Average rate of change. And we've already seen that, haven't we? We've had to worry about things, how things change. So miles per hour is a rate of change. Feet per second is a rate of change. Right? Dollars per pound is a rate of change. Rates of change.